Lecture 3 on electrochemistry. We're still trying to build a galvanic cell, and we're using this MnO4 minus Fe2 plus redox reaction. So let's just take a look at what the board says. So we're trying to separate these things into two separate half reactions so that we can get the electrons to transfer in a wire between these things. So it says the key is to separate the reducing agent from the oxidizing agent. And so now any electron flow between them can take place through a wire. So you got this Fe2 plus here and MnO4 minus over there. You have a metal piece dipping down into the solution, and you have a metal wire going from one to the other. And we're just going to try to look at the electron flow through that wire. So then, if you were trying to use this to power something, so you're going to get work from the chemical reaction, you'd stick a battery right here. So you just you'd cut the wire and connect one end of the wire to one side of the battery and the other end of that wire to the other side of the battery. And if you got good electron flow and good voltage, that motor would start to turn. Okay, so it then says we then connect the motor to the wire and extract energy from the flow of electrons. Okay, so our first attempt, we dip a couple metal strips in each of two beakers. We put the reducing agent in one beaker and the oxidizing agent in the other. And I just wrote a little note over here on the other side. It goes, in real chemistry, the ions would come from a salt, so there would be a counter ion present in each beaker. That just means that there'd be a negative ion in this beaker with this Fe2 plus, and there'd be a positive ion in that beaker with the MnO4 minus. Because that's the way real chemistry works. Okay, so underneath this thing it says this is a smart start. It's a smart start because you isolated the reducing agent from the oxidizing agent, but it doesn't work because the minute electrons move from Fe2 plus to MnO4 minus, a negative charge builds up on the left. So if you started moving electrons over here, a negative charge would build up here and a positive charge would build up here, and that would make the electrons not want to flow anymore because likes repel. So why would a negative thing want to go to something that's negatively charged, and why would a negative thing want to leave an area where positive charge was building up? Because the opposites would attract here and likes would repel over there, stopping the electrons from flowing. And so this little situation, even though you're somewhat smart here, it doesn't work because a negative charge builds up on the left, a positive charge builds up on the right, and that stops electron flow. So, the little man is not happy. You got to remember all chemical systems start as neutral. So there's equal numbers of protons and electrons in each beaker. And if you move charge, the system becomes charged, and nature doesn't like charge buildup. And the reason for that is the minute, if you start getting a substantial area of negative charge or a substantial region of positive charge, charges create much larger forces than, say, the force of gravity. And so you get huge charge buildup, you get huge force buildup, and that's not something that nature allows to have happen. And so nature does not like charge buildup. I'll just say that for a fact. Okay, so that leads to this thing that, like, what our battery needs is a way to transfer negative charges without negative and positive charges building up. And so to do this, what you're going to try and do is you're going to have a single electron, a negative charge flowing this way, be accompanied by a positive ion that flows this way. So then the positive ion and the negative electron match charges, and so you don't get any charge buildup in this beaker. And you don't get any charge buildup in that beaker either, because a negative and a positive are leaving together, and a negative positive are arriving together with the other beaker. And that keeps charges in balance, which allows flow to keep happening. So to do this ion flow type stuff, so they're going to try. So to do this, we'll match ion flow inside the battery to electron flow outside the battery. So this is flow outside the battery, flow inside the battery. We'll just take a look at it. So there's three ways of allowing ion flow that people came up with in little experimental battery or galvanic cell situations. One is to build a salt bridge. So this is a bridge between this solution and this solution. That this is a liquid bridge between the two solutions that allows ions to flow from the one to the other. And then what they do sometimes is they have a fancier glass maker make two beakers that are connected by an actual glass bridge, and they put a porous disc in the middle because they don't just want the two solutions freely mixing. So they put this porous disc in there. It's kind of a porous disc is kind of just like a piece of styrofoam you stick in there, and things can migrate through it, but it keeps the two solutions from freely mixing. So now this porous disc and this glass bridge are going to allow positive ions to flow. When an electron flows this direction, a positive ion will accompany it. And then you also have these things called porous cups. They're actually quite expensive. So they're a little bit like a styrofoam cup, only they're a fancy form of, they're kind of like a fancy form of china, and they allow certain ions to flow through them pretty freely, and they don't allow other ions to flow through them. So these porous cups, you'd set it down in here, and now you basically have a two beaker type system. The porous cup forming kind of one beaker where the Fe2 plus solution is, and the MnO4 minus solution being in the beaker outside the porous cup. And then then you'd also have a wire going in all these, because that wire would be carrying the electrons, and then the bridge and this porous disc and this porous cup would be allowing ions to flow in the solution while the electrons flow in a wire outside the solution. So in terms of just the simple thing that's going to happen, the electron flowing this way is going to be accompanied by a positive ion flowing that way. And that means you got a plus and a minus that cancel each other out, meaning no charge builds up here. Because the plus and the minus left here, no charge builds up here either.